In this video, I'm going to calculate the modulus of elasticity. This is a BTEC Level 3 exam question from January 2020. We need to calculate the modulus of elasticity, so I'm going to find out which is the formula that I have to use to be able to calculate it. This is an extract of the booklet that you will get the day of the exam with all the formulas that you may need. And here we can see the formula of modulus of elasticity. Capital E, which is the letter that represents modulus of elasticity, equals sigma, which is a Greek letter that represents a stress, over epsilon, which is another Greek letter that represents the strain. And in this same booklet, we have the formula for the stress and the formula for the strain. Now we can start with the problem. The contractor has carried out tests on the concrete that has been used for the floor. This is part of the scenario. The original thickness of the concrete floor slab was 200 millimeters. We are going to draw this because using a drawing always makes it easier for us to understand the problem. During a test, a load applied to the concrete compressed it by 0.04 millimeters. This load is going to push down, compressing the concrete a distance of 0.04 millimeters. The stress in the concrete has been measured as 40 times 10 to the power of 6 newtons per meter squared. Calculate the modulus of elasticity of the concrete. The formula of the modulus of elasticity is this. E equals sigma, which is the stress, over epsilon, which is the strain. We know the stress because it's in the question. So the stress is 40 times 10 to the power of 6 newtons per meter squared. And the strain is the change in length, represented by this Greek letter called delta, over the original length. The change in length is 0.04 millimeters over the original length, which is 200 millimeters. And the strain is 2 times 10 to the power of -4. Strain has no units. So the modulus of elasticity equals the stress, which is 40 times 10 to the power of 6 newtons per meter squared, over the strain, which is 2 times 10 to the power of -4. And this equals 2 times 10 to the power of 11 newtons per millimeter squared. And this is the answer.